Friends, welcome to RR Digital. So today I will explain briefly about Hive model. So how Hive model came into market and what all are the companies they are using Hive model and what is the use of Hive model and what all are advantages and disadvantages are there in a Hive model. So those topics I will cover in this model. Okay. So basically Hive model uh, initially developed by Facebook company. Okay, so long back when HDFS and MapReduce came into market, that time there is no Hive model. Okay, so MapReduce model only Java people can able to write a code. Okay, but non-Java programmers there is no component in big data Hadoop. Okay, after that Facebook company implemented this Hive model for non-Java programmers. Okay, so in a Hive model completely we have to use only queries. These queries similar to your SQL queries. Also, this Hive model it will support only structured data. It will support only structured data, not other data. Okay? Only structured data. So initially, Hive model came from which company means Facebook company. After that, this Facebook company hand over this Hive model to Apache software company. Okay, so now entire Hadoop and Spark from which company means Apache software company only. But initially, this particular component implemented by Facebook company. But later, this Facebook company hand over the Hive component to Apache software company. Okay, so what types of data this Hive model support? Okay, so Hive only structured data purpose that they implemented. Okay, because here we have to write queries. So queries means basically it will support only structured data. So Hive doesn't support any semi-structured or unstructured kind of data. Basically, most of the real-time companies they are using this Hive component to process only structured data, but semi-structured and unstructured data they are using other components. Those components we'll discuss in later classes. So topics I'm going to cover introduction to Hive, okay, and manipulating data with the Hive. So how to manipulate the data in a Hive model, also how to retrieve data, how to delete the data, also how to apply partitioning and bucketing concepts in a Hive model. Also, not only partitioning and bucketing, here we have some new features. Those features not available in SQL or RDBMS. So, what are the new features available in Hive model? That also I will explain under advanced Hive features concept. So Hive best practices means here practical. So in Hive model, basically here less theory and more practicals. Okay. So I will cover all the topics in Hive model. Okay. So in real time, what all are the topics we are going to use? Those topics I will cover in Hive model. So again, in introduction to Hive, we have few subtopics. What is a Hive and what other advantages is there in a Hive model, and what is a Hive architecture, how it will process your data. Also, how to create tables in a Hive. What types of tables are there in a Hive model? How many types of tables are there? Also, how to load the data into Hive tables. Okay, so generally after creating table, we have to load the data into table, right? Okay, so those concepts also I will cover in a Hive model. Also, how to store data. Also, how to retrieve the results from HDFS that will cover. Also, how to create different types of schemas or databases. Okay, so when I start practicals, I will give more knowledge about this databases concept. Okay, so first topic, what is a Hive? Okay, so Hive basically it is a open source software only, but they implemented this Hive component on top of HDFS. Okay, so storage capability only HDFS having. Okay, so using a Hive model, you can process your data and you can store your data inside HDFS. And again, whenever you want, you can read data from HDFS. That's why they implemented this Hive model on top of Hadoop or HDFS. Okay, Hive full abbreviation, high performance integrated virtual environment. Okay, so this is the full abbreviation for Hive component. Also, basically this Hive model they implemented for non-Java programmers already we discussed. So basically, whether from SQL background or uh, data warehousing tools background related people, they can use this Hive model and they can process a data. Okay, because compared to Java model, Hive model is very easy, right? Because everyone, most of the companies, even if you use Java or if you use .NET, any technology, everyone by default they should have knowledge on SQL, because back in most of the companies they are using SQL. That's why 80% people by default they will have knowledge on SQL. Okay, so SQL it is very easy to learn. Okay, so here based on this SQL model they implemented this Hive model. Okay, so basically this they implemented for non-Java programmers to access the data from Hadoop clusters. So Hive supports basically SQL queries, but not all the SQL concepts. Only few concepts it is supporting from SQL, and the remaining concepts they implemented newly in Hive model. Okay, so SQL means basically structured query language, right? Okay, so here Hive we have to call a HQL language. HQL means Hive query language. RDBMS generally SQL will call SQL, right? A structured query language. But here Hive we have to call HQL language. H means Hive, Q means query, L means language. So HQL generally it supports all the tables. You can create tables and you can store your structured data inside those tables. On top of that, you can apply your filters or aggregation functions or joins, whatever you want, you can apply. Okay, so all the built-in functions available in HQL also, like SQL. Okay, also here you can implement some HQL scripts. Okay, so inside that scripts you can write a number of queries. Whenever you will execute that particular HQL script, all the queries one by one it will execute, and it will store your data. So based on your queries it will execute. Okay, Hive also includes metadata. Okay, so two concepts here. Okay, one is metadata and the second one is actual data file. Okay, so we are talking about only Hive here. Okay, so don't confuse. For example, now here you can assume I am creating a table. So create table, some table name. Okay, so here I n number of columns. Okay, so I created table. Okay, so when we create a table here, basically column names and each column related data types will specify, right? Okay, those all will call as metadata. So column names and data types. Okay, and the same time a table name also, also which location that particular data stored. Okay, so these all will call metadata. So this metadata, this metadata it will store inside RDBMS. Okay, so whenever Hadoop admin team generally they install Hive software, with the Hive software, they install one RDBMS also. Like based on their requirement, Oracle or SQL or PostgreSQL like that, they will install RDBMS. Okay, so metadata information it will store inside RDBMS. Okay, but after creating table, you have to load the data into table, right? So while loading the data, okay, so now you can assume you loaded your data into MP table. Okay, you have one data file. That data file name may be employee.txt. Okay, that particular data, actual data file, it will go and it will sit inside a HDFS. So whenever you are creating table, that table related information, schema related information, it will store inside metadata. So metadata means RDBMS, and your data, actual data, it will store inside HDFS. User trying to retrieve the data. Okay, select a star from maybe AMP. Okay, so first it will go to metadata RDBMS. It will check, okay, this particular employee table existed or not. Inside metadata, if employee table existed, then only it will go to HDFS. From here it will read your data. In case you was trying to read EMP1, then also it will go here. First it will check EMP1 table is there or not. Table not there, right? If table not there, then it will not go to HDFS. Directly it will throw error. A table does not exist. So first point of check for any table in a Hive model, that is metadata. First it will check metadata. If metadata, that particular table or column or schema existed, then only it will go to HDFS for reading or storing. Okay, so that is about Hive metastore data, how it will create. Okay, and Hive implementation at Facebook contains tens of thousands of tables. Okay, so generally we know, right? Facebook daily millions of customers, uh, they will post different varieties of data like images or structured data or comments or videos. Okay, so for a day it is generating more than 700 terabytes of data. Facebook is generating for a day more than 700 terabytes of data. So once the data will generate, immediately they will store inside HDFS. On top of that, they will do uh, analytics also, analysis they will do. And what other advantages are there in a Hive model? If we use a Hive model, what other benefits are there? Okay, so basically Hive is easy to learn compared to other coding languages because Hive model implemented based on SQL. Also, HQL queries is much faster than a Java code. Okay, so for example, here, if you want to create a table and if you want to store data, only two queries, two lines of code is required here. But same, if you want to implement in Java, you have to write more code, maybe 50 to 100 lines of code is required. So there more time will be waste, and again you have to compile that code. Again you have to add all the required dependency jar files. Okay, so that's why nowadays. Instead of using Java in a big data Hadoop, they are using a Hive component to process structured data. Okay. Also, manipulation of the data also very easy in a Hive model. Okay. So, but Hive generally is not a relational database, and Hive is not designed for online transaction processing. But our DBMS is designed for online transaction processing. Okay, but Hive is not designed for online transaction processing, but you can store offline data. Okay, also we have few features in Hive model. It stores your data inside a database, specific database. So whenever you want to store your data, compulsory you have to create a specific schema or database. Also, Hive is designed for OLAP, and generally Hive will call a HQL or Hive query language. Okay, and compared to other languages, it is very fast and scalable and extensible. Okay, scalable and extensible means you can use built-in functions. Okay, with Hive software, built-in functions will come. Like if you want to convert into uppercase, built-in function is there, you can convert. Okay, but in case if you want to implement your own functionality in a Hive, okay, using Java or other language, you can implement your own functionality. After that, you make a jar file. That jar file you can integrate inside a Hive model, then it will work. That is called extensible. And the Hive metastore, this we discussed, right, where metadata it will store and where the actual data it will store. Okay, so actual data it will resides inside a HDFS path, and the metadata it will store in a RDBMS. Okay, so what is metadata means? Your table names, column names, and data types. Also actual data storage path or data store path. Okay, also schema names. Okay, database names or schema names also it will store inside metadata. So now we'll discuss about the Hive architecture. So Hive queries we can execute in different prompts. One, you can execute from PuTTY. PuTTY means command line interface. Okay, so if we execute from command line interface PuTTY, backend built-in drivers available. Okay, these drivers it will come with your Hive software. So those drivers it will compile first your query. Okay, so if there is no errors, then it will optimize and then it will start executing. So while executing, backend it will connect to your HDFS model for storing or retrieval purpose. Okay, so here driver whatever are available, these all are built in now. Okay, so we no need to worry about. Okay, but that query while compiling, uh, if any errors are there, then it will throw error in PuTTY itself. Okay, so if you use PuTTY or if you use a front end, here we have one web user interface also, that is called a HUE model that we'll discuss in later sessions. So using a front end also you can execute your Hive queries, not only back end PuTTY, even front end also you can execute same Hive queries. Okay, if you use front end also, first it will connect to drivers, it will compile, after that it will optimize, then it will start executing your queries. Okay, so here on top of this HDFS only, this Hive model they implemented. Okay, now to connect a HDFS server, Hive you can use a Java code also. Using Java code also you can create a tables or you can load the data. So JDBC, ODBC concept is there. Okay, so using a Java you can implement that JDBC code. After that you make a jar file. That jar file, this script server basically it will help that jar file to connect these drivers. Okay, so script server, this is basically built-in jar file. Okay, so this built-in jar file, whatever Java jar file you are executing, okay, it is basically mediator between your Java code and this drivers. Okay, this will help you. Okay, so even the Java code also, these drivers will verify, then it will connect to HDFS. And here meta data. So metadata we discuss. See, if we execute from backend or if we execute from front end or if we use Java code, okay, so anything this metadata is common. Okay, metadata. So your metadata it will store inside RDBMS and your actual data it will store inside HDFS module. So here SQL queries, okay, so few commands are there and a few commands basically Hive is supporting and a few commands Hive doesn't support. So we have different commands in SQL, right? DDL, DML, DCL, DRL, and TCL. Okay, so here Hive supports DDL, your DDL commands. It will support under DCL, DRL, DML views. Also indexes from SQL it is supporting. Also joins, partitioning concepts and aggregate many functionalities your Hive module supporting. Okay, but a few functionalities Hive not supporting. So TCL, okay, TCL means commit, rollback and save point concepts are not supporting. Okay, because here auto commit in a Hive everything auto commit, but in SQL manually we have to click a commit button, right? So here everything auto commit. Okay, so TCL commands not supporting, triggers also not supporting Hive. Also stored procedures uh, also not supporting. There is no primary key, foreign key, keywords or concepts in a Hive model. It is not supporting. Okay, so only a few topics it is supporting from SQL, and a few topics it is not supporting. Hive it is supporting different types of data types. So tiny int 1 byte it is supporting, small int 2 bytes and integer 4 bytes, big int 8 bytes, also float single precision and varchar also there it is supporting, double boolean timestamp. Okay, these all are different data types already uh, SQL also supporting. Okay, here if you see varchar and string. Okay, so string basically it came from Java. If you specify string means it will support anything. Okay, even if it is numbers or characters, even varchar also same. Okay, so you can define varchar or string, that is up to you. Okay, but both it will support any type of data. Okay, but thing is most of the real-time projects instead of varchar they are using a string data type. Okay, this is about data types. Okay, so first we'll see how to log in into Hive mode. So if we want to execute any queries in a Hive, so compulsory we have to log in into Hive mode. So in Cloudera VM, to log in into Hive mode, here we have to give Hive a semicolon. Hadoop admin team they will give one more secure line command. Okay, so in real time in our virtual machine in a Cloudera quick start VM, we have to give Hive semicolon so that it will enter into Hive mode. So now I'm inside the Hive mode. So here you can execute your Hive related queries. Okay. So now I want to check what all are the databases or schemas available in Hive. Okay. So here show databases. This is the command. It will list all the available databases or schema names. Okay. So as of now, it is showing only one schema name, that is a default. Okay, so whenever you want to see list of databases, compulsory you have to use the command show space databases. Now I want to create my uh, own database. So how to create a new database or schema? So here create database, then database name. Okay, so here database name I'm giving RR digital. Okay, so successfully created a database, right? Whether database created or not. So again we have to execute a show database. See here it is showing a RR digital database. Okay, so now how to select a database? So here we have a total two databases. Okay, but I want to create tables. Those tables has to create inside a specific database, inside a specific database. So at the time you have to choose your database, under which database you want to create tables. Okay, so how to choose database? So here use then database name. Okay, so I have selected a database name default. So now onwards in this session, whatever tables I will create, all those tables it will store inside this default database. Okay, so now I have selected database, but I want to see list of tables. What are the tables available under default database? So how to list out existing tables? So here show tables. So this is the command. Okay, so right now there is no tables. Okay, so we have to create our own tables. Okay, so even single table also not existed. So now we'll discuss about how to create a tables. But before going to tables creation, first we'll see how to remove database. So creation we know how to create, but how to remove a database. Okay, so here drop database, then database name. Okay, so this is the command. It will help you to remove the database. So successfully removed. Now again I will cross verify. Show databases. So successfully removed. Now it is not showing right RR digital. Okay. So drop database and database name. It will help you to remove the databases. I want to create a again database. Okay. So we can use same create database name. Okay. So show databases. Okay. So now it is showing RR digital. How to create tables. Okay. In a Hive, we have two types of table creation. Okay. One is internal table. Second one is external table. Okay. So how to create internal table and how to create a external table. Again, in internal table, we have two concepts. Okay. With location, how to create, and without a location, how to create a internal table. So even external table also.
How to create with location and how to create without location.
So first we'll see how to create an internal table. So if you want to create a table, first you need a data file, right? Okay. So let me open one more window here, duplicate session. Okay. So here username Cloudera, password Cloudera. Okay. ls cd data. I have few sample data files. ls. So here I have one data file cat employee.txt. Now for this data file I have to create a table. So this looks like employee number, employee name, phone number, salary, and maybe a department uh, number. Okay. So how many columns required? Total 5 columns required. While creating table, total 5 columns we have to define. Okay. So now in a Hive mode, create table, table name employee. Before this, let me choose schema. Now I am creating create table employee. How many columns required? Total 5 columns, right?
So employee number, data type int, and employee name, data type string data type.
Phone number. So phone number we can give int or begint. Okay, int or begint we can give, and then next column salary int I am giving, and the next department a number, department number hint. So all the column names and the data types I specified are here. Okay, and then row format delimited fields terminated by. So in data file your data separated by which symbol. So here if you see your data separated by pipe symbol. Okay, if your data separated by pipe, you have to specify pipe. If your data separated by comma, you have to specify comma. So while creating a table, you have to specify delimiter. Okay, so what is the meaning of this row format delimited fields terminated by means? Row means in our data file, data row wise, data is there in row wise. Format delimited fields terminated by. Fields terminated by means each column here, between each column it is separated by which symbol. So that symbol we have to specify here. Okay, so now successfully created a table. Okay, so how to check a table created or not? Show tables. So here it is showing a table. Okay, so select star from employee. So no data because we just create table but the data not yet loaded. Okay, so we have to load the data. Okay, so now we are discussing about without location concept. Okay, here without location concept we are discussing how to create internal table and without location. Okay, now how to load a data file. Okay, so your data file where it is located, your Linux operating system local file system, under this path it is located. Okay, home cloudera data. Okay, so now how to load a data file into this a table. So here load. So now we are trying to load data file from local file system to Hive table. Okay, load data local in path. So local file system path where the data file existed, home cloudera under data employee.txt file. So this is the file we are loading into table. So this data file you want to load into which table? That table name we have to give employee table. Okay, so successfully loaded data. So now we'll see data loaded or not. Select star from employee. See data loaded. Okay, so on top of this data now you can apply anything. Okay, even you can apply aggregation functions or whatever you want. Okay, data loaded successfully. Even you can apply where conditions like select from employee where salary greater than maybe 5,000. Okay, so here if you see data it is populated only more than 5,000 related. So once you load your data file into a table, you can apply any operations. Even you can apply joins or you can apply aggregation functions, whatever you want you can apply. Okay, so this is about your internal table without location. So now we know how to create a table, the data from local file system to Hive or HDFS. We know now, right?
We'll see how to describe a table. So first we'll check what other tables available in database. So for that we have to give show tables command in a Hive. So here it is showing only one table, that is employee table. Now I want to see what other columns and data types are defined for this particular table. So for that we have to use a describe command. So describe then table name. Okay, so these all are the commands available for employee table. So columns and data types it is showing. Okay, and here similarly we have one more query, describe extended. Okay, so here describe extended means it will give full information. Okay, full means that particular table name and that table is related to which database and who is the owner for that particular table and what time exactly that particular table is created. Okay, and exactly under which directory that particular table is created. Okay, so what is the difference between describe and describe extended? So describe means it will just give you only column names and the data types, but describe extended means it will give full details. Okay, so full details means that particular table related columns and the data types, along with that who is the owner for the table, and what is the table name, and exactly which date or what time exactly that particular table is created, under which directory that particular table is created, and is it a external table or it is internal table. So whenever you want a full information, that time you have to use describe a extended command, or else you can use only describe command. So describe command, it will just give you only column names and data types. So this is about describe and describe extended. Now, how to rename a table in a Hive? So I want to rename a table. Okay, so here I have a employee table. Okay, so this table I want to rename to EMP table. So how to rename a table? So alter table, table name employee, rename to, and here we have to give new table name. So new table name, here I am giving EMP is my new table name. Okay, so successfully renamed. How to check whether the table is renamed or not? So again we have to use here show tables command. See, old table name is employee, but now it is showing table name as EMP. So whenever you want to rename a table, we have to use this command alter table name and rename to your new table name. Not only table rename, automatically data also it will come. So here select star from EMP. So whatever data available in employee, same data it will show for EMP also. Okay, so this is about how to rename a table. Now I want to add one new column to the existing table. Okay, so right now here if you see describe employee means how many columns are there, describe okay, not employee, right? We have EMP table now. Okay, so only 4 columns and 4 data types. Okay, but here I want to add one more new column, that is maybe you can assume a department number new column I want to add to existing Hive table. So alter table name EMP table, add elements. Okay, so here a new column name and then new column related a data type we have to specify here. Okay, so successfully added new column to existing table. Now we'll cross verify whether a new column added to EMP table or not. Okay, so successfully added. Now earlier it is just 4 columns and 4 data types, but now it is showing 5 columns and 5 data types. So whenever you want to add any new columns to existing table, compulsory we have to use add columns command. Now we'll see how to connect RDBMS. Okay, so generally earlier we discussed that metadata it will store in RDBMS and actual data it will store in HDFS, right? So now how to connect to RDBMS? Okay, so here to connect RDBMS, MySQL hyphen u root hyphen p. This is the command to connect RDBMS, and it is asking a password Cloudera we have to give. Okay, so successfully connected MySQL database. So here I want to see what all are databases available. So databases. So here there are multiple databases available in this, but under which database exactly metadata will store means under metastore database our tables related metadata it will store. So use metastore. Okay. So now we'll see EMP table related metadata available under this database or not. Okay. So here select from TBLS. So this is the command basically to check your table related metadata. So whenever you want to check metadata available or not, at the time you have to use this command. Okay, so here it is showing your table related metadata. So here this is your table name, and here it is telling it is internal table or external table. Internal and managed means both are same only. Managed table means internal table only. Okay. In real time, generally to connect RDBMS and to check metadata, Hadoop admin team generally they will not give you access. Okay, but here Hadoop software we installed in our personal laptop. So just knowledge purpose, I'm explaining how to connect RDBMS and how to check a metadata. So again, if you create one more table, so under this, whenever you will execute this query, by default, one more table related metadata also, it will show here. So this is about metadata, how to check metadata. We'll discuss about external table. So external table we have with location and without location, two concepts. So first we'll create one external table. After that, will load data into external table. So we'll see both the concepts with location and without location. Okay. So how to create a external table. Okay. So before creating external table, you need a data file. Okay. So duplicate session, Cloudera, CD data. Here I have some data files. Okay. So whenever you want to create a table, first you should know which is data file and what other columns available in the data file. So cat employee.txt. Okay, so here this is the data file. So total 5 columns: employee number, employee name, phone number, salary, department, a number. Okay, so create external table name, employee one I'm giving. So internal table we have not specified external keyword. Okay, so how will recognize it is the internal or external table means if you give external keyword means that is external table, but if there is no external keyword means that is called a internal table. By default it will consider a internal table. So here I'm specifying column names and data types. So phone number, data type big int, salary int, department number int. Okay, so row format delimited, fields terminated by. So your data separated by which symbol? Okay, so here our each column related data separated by pipe symbol. Okay, so here we have to give pipe. Okay, so now we are creating table for without location concept. Okay, so table created successfully. So we can cross verify table created or not. Show tables. So here successfully created your employee one table. Okay, even you can verify metadata also here for employee 1 metadata created or not. Okay, so here it is showing, so employee 1 also metadata created. Okay, now we have to load the data, right? So we just created a table, but we have not loaded any data, so it is giving empty results. Okay, so now we'll load the data. Okay, so load data local in path. Okay, so my data file available in Linux operating system in local. Okay, so pwd, so under this folder, under this path, employee.txt file I available. Okay, so here I'm specifying data file path. Okay, into table. So this data file I want to load into which table? Employee 1 table. Okay, so successfully loaded data into employee 1 table. So now we'll check whether data loaded or not. So successfully loaded and data populating. Okay, so using your select query you can check data. Okay, or else backend also using your Hadoop command also you can cross verify whether data loaded or not. Okay, so this is about external table with location, without location, sorry, external table without a location. But here while loading data, load data local in path I used, right? In path. Then here file path I specified, right? File path. So why this local keyword we have to give? And even without giving a local keyword also we can load data. Okay, so like this, load data in path, then your a file path. Okay, so what is the difference between this query and this query? Okay, so if you specify local keyword means you are loading your data file or your data from local path. That means your Linux operating system. Your data file located in a local path. That means you have to give your a local path. Okay. If you not specify local keyword here, that means you are loading your data from a HDFS path. So your data file already there in HDFS. That data file you are loading into just a Hive table. Okay, so here you have to give your HDFS path, HDFS file directory. Okay, so user Cloudera, then maybe a data file. Okay, so if you give local means you have to load data from your local path. You have to give local path directory. If you not specify local keyword means you are loading your data from HDFS to Hive table. So here you have to give only HDFS a path. So this is the difference between local and without local. Okay, so if local is there means you are loading data file from local. If you're not specifying local keyword means you are loading data from HDFS to Hive table. Okay, and now we'll discuss about with location. Okay, without location we created one external table, right? Now with location how to create. Okay, so before that I will just copy one data file to HDFS location. Okay, so how do let me create a first one directory inside HDFS. Okay, Hadoop fs -mkdir user Cloudera employee. Okay, I'm creating one directory. Employee 2 directory I'm giving. So employee 2 directory created. Now I will copy one file from local to HDFS under employee 2. Okay, so here copy means a put command we have to use and our local path. Okay, so source path home Cloudera data under data employee.txt file. So this file we are copying under employee to directory in HDFS. So local to HDFS we are copying data file. So we'll just cross verify under employee to data file available or not. So data file available. Now we'll create external table with location. Okay. So here Hive. Okay. So while creating a table, I'm giving a location also, file location also. Okay, file location user Cloudera employee one directory. Okay, so here only till directory we have to give. No need to give file name. Under this directory, even if 10 files or 20 files also, all the data it will load into this particular table. Okay, so here I'm giving employee to see it will create a table, same time it will load data also in this table. See, earlier we discussed without a location concept. Without location, two queries. One is create table statement separate, another one loading data query is separate. Okay, but with location concept, single query itself we are loading a data file also. Okay, so this query it will create your table, same time it will load the data also. So here create external table name employee 2. Okay, and then row format delimited fields terminated by and location HDFS path. I'm not giving here file name. Okay, so under this employee 2 directory, whatever files available, even if it is 10 files or 20 files, all the files related data it will load into employee 2 table. Okay, so select star from employee 2. Okay, so successfully loaded all the data files. So this is about the external table with location and without a location concept. How to insert data from one table to another table. Okay, so here first we'll verify what other tables available. Okay, here I have multiple tables, employee, employee 1, employee 5, like that. Okay, so here employee 5 table I have some data. Okay, so employee 5, right? So employee 5 data I have 47 records. Okay, but inside employee table there is no data. So now how to insert the data from employee 5 to employee table? So whatever data available in employee 5 table, same data I want to insert into a employee table. Okay, so for that, how to write a query? So here insert into table. So data you want to insert into which table? Employee table. Okay, and then from which table? Okay, so select a star from employee 5. So whatever data available in employee 5, same data I'm inserting into employee table. Okay, so backend here map reduce jobs are running. So successfully executed. Now we'll cross verify employee table it is showing data or not. Okay, so successfully I inserted data from one table to another table. So like this we have to insert data from one table to another table. Now next concept, how to execute Hadoop commands in a Hive prompt. Okay, so generally in a Hive prompt or Hive mode, we'll execute only Hive queries, right? But to execute Hadoop commands generally in separate window, here we are executing Hadoop commands. But I want to execute Hadoop commands also inside a Hive prompt or Hive mode only. Okay, so for example, I want to list out what all are files or folders available under HDFS path. So generally for that we'll write a query like Hadoop fs-ls, then a user Cloudera. Okay, so whenever you want to execute your Hadoop commands in a Hive mode, in front of the any command we have to give the symbol, then only it will work. So successfully executed your Hadoop command inside a Hive mode. So these all are the files and folders available in HDFS path. Okay, so same way, even you can execute your other commands also, like for example cat command. Okay, employee.txt. Okay, so here instead of ls you can give cat, and then here same this symbol we have to specify. So now I want to execute a Hive queries without a Hive prompt. So how to execute? So here I have not logged in a Hive mode in this window. Okay, but here I want to execute Hive queries. So how to execute? So here, for example, I want to execute a select a star from employee table. Employee table. So this table is there in which database? Okay, so that database we have to choose. Use RR digital. This is the database. Okay, and here Hive hyphen e means execute. Okay, and entire query we have to specify inside double quotes. So we are telling you can execute this in a Hive. Hyphen e means execute. So before executing query, you choose RR digital database. From RR digital database, this particular table related data you can retrieve. So total 47 rows. Okay, so successfully executed Hive queries in local file system without entering in Hive mode. We have executed Hive queries using this command. Okay, so we know how to execute Hadoop commands in Hive mode. Same time we know how to execute Hive queries in a local file system. Now, how to import specific Hive table data from Hive to local file system, local file system, local file system or HDFS file system. Okay, so I have one table. Okay, the table contains some data, but I want to import the data to local file system, or I want to import into HDFS path. So how to import a specific table related data? Okay, so for that we have to write a query. So here I want to import employee table related data into local file system. First I will import into local file system. So here insert, overwrite local path. So in local, where you want to import this data? Okay, under home, Cloudera, new one. So new one directory it will create. Under new one directory it will import your employee table related data. Okay, and while importing data, each column should be separated by which symbol that we have to specify. So row format delimited fields terminated by symbol, pipe symbol. Okay, so this particular Hive table related data I am importing into local file system under this directory. Okay, so insert overwrite local directory and then a local directory path, row format delimited fields terminated by, and then a select star from table name. So now we'll cross verify data imported into local file system or not. Okay, so here pwd ls, so here new one directory created, so cd new one, and then ls. Here we have data, so data imported successfully. Okay, so 47 records. So whatever data available in Hive table, same data successfully imported into local file system. So same way, how to import a specific table related data to HDFS path. So here HDFS means local keyword not required, and here we have to give HDFS path. This is my HDFS path. Okay, new one directory it will create. So now we are importing data from Hive table to HDFS path or HDFS. Okay, so successfully we imported data. Control L. So we have to cross verify, right, the data imported or not. So Hadoop fs hyphen ls user cloudera under new one directory data imported or not will check. So here it is showing. So using cat command we can check, right, use. Okay, so successfully imported data. Okay, so next concept, manipulating data with Hive. So like how to manipulate data or how to retrieve the data from specific table. Okay, so here again we have few topics. Okay, so mainly how to apply joins on different tables, and how to apply select statement or select query. Also here we have a few functions like aggregate functions and string functions and the subqueries. Okay, so these are the different concepts in next sessions we have. Also DML commands like insert, update, delete. So update, delete, Hive is supporting or not. If it is supporting, from which version onwards it is supporting. So those concepts will cover in the next few sessions. Also, we have few important topics in Hive. One is partitioning, and then bucketing, and then sampling, then complex data types. Also, we have a few user-defined functions. So these are all the topics I will cover in the next few slides. So now, how to retrieve data from table that we already seen. Also, we know how to apply uh, where class or how to apply a limit, like if you want to restrict rows, how to restrict. Okay, those all we already seen. So here a basic syntax I given here for where condition and for order by, also limit also. Okay, so here if you want to apply where condition, so select star from employee where salary greater than amount. Okay, so we can apply same way like here 45,000 means only 3 records. Even if you want to apply order by ascending also you can apply. So limit, here we can apply limit. So limit 1 means only one record that is showing. Basically more than 45,000 salary related we have 3 employees. Okay, but here I restricted to only one record, so that's why it is showing 1. Okay, and here we have sort by and order by concept. What is the difference between order by and sort by? Okay, so order by basically it will give ascending or descending, like if 10 records are there. Okay, select start from employee, order by salary, ascending. Okay, so all the records salary ascending order, like first lowest salary related employee details, then highest. So ascending means low to highest, right? See here, first lowest salary it is showing, then highest salary. Okay, so same way descending also we can specify descending order. So descending order basically in a Hive, first highest salaries, then lowest salaries it will populate. Okay, so descending order, first highest, then lowest. Okay, so that is about ascending and descending. And here we have sort by and order by. Okay, so both are same only, but the difference is order by, here sort by. Okay, so order by always it will give correct result. In real time, 90% people they will use order by only, because it will give correct results. Okay, but the sort by, if you have only one mapper, one mapper means your data is there in entire data is there in only one mapper means, then it will give correct results. But if your data is there in multiple mappers, then it will give wrong results. Okay, so because sort by it will apply sorting on each individual mappers related data, but order by it will apply on all the mappers related data. That's why order by always it will give correct result, but sort by whenever multiple mappers are there, inside those multiple mappers different data is there means it will give partial results. That's why always we have to use order by. So in a Hive we have different types of joins. So one is a inner join. Okay, second one left outer join, third one right outer join, fourth one full outer join, fifth one cross join. Okay, so inner join. So basically if you want to apply any joins, okay, so here joins. Okay, so if you want to apply joins, so first we need 2 tables. Okay, so joins always we have to apply on multiple tables. Okay, so here first we'll create one table, that is employee table, and the second table will create a department table. Okay, so if you want to apply joins on 2 different tables, compulsory one common column should be there in both the tables. Okay, so here you can assume employee table, you have department number is the common column, and the department table also you can assume department number is the common column. Okay, So on top of these two tables, we have to apply joins. Okay. So first one is inner join. So this inner join, okay. So basically in both the tables, this particular department number will match. Okay, only those records will populate. Okay, for example, here employee table. Okay, I have employee number 100 and department number 1 and maybe a name. Okay, and again here department table, I have a department number. Okay, and name. First you can assume department name, then department 1, and then here again department description. Okay, so when you apply inner join, okay, this is department number column in employee table, this is department number column in department table. So both the records department number is matching. Okay, so wherever both the records department number will match, so only those records it will populate. Okay, so that is about inner join. Okay, left outer join. Okay, so left outer join means, so here also you have two tables. One is employee table, that is you can assume left side table, and department this department table you can assume right side table. So here left outer join means left side table all the records it will populate, but the opposite side table only matched records. So left outer join means left side table all the records, but opposite side only matched records. Okay. Now right outer join. Okay. So right outer join also similar to left outer join. So right side table all the records. Right side table all the records, but opposite side op- opposite side table only matched records. Okay, so opposite side, or you can assume left side table. Okay, because right side table all the records means left side table only matched records. And fourth one, full outer join. So basically full outer join means from both the tables all the records, even left side table all the records and the right side table also all the records. And next here we have fifth join, that is a cross join. So basically cross join means left side table each record it will map with all the records from right side table. So left side table first row, okay, it will map with all the records from right side table. Again second record, okay, like that. Also here, so for example you can assume this is a left side table, okay, and this is a right side table. Okay, so left side table you can assume I have only three records. Okay, maybe record number 1, record number 2, record number 3, only 3 records. Okay, and here right side table also I have only 3 records. Okay, and here one more record. Okay, so cross join basically how it will apply means left side table first record it will map with all the records from right side table. Okay, again same record it will map with other record. So like this each row it will map with all the records from right side table, that is called a cross join. Okay, so similar way your second record also, again second record also it will map. Okay, so this is called cross join. Even your last record also, so last record also it will map with all the records. So this is called cross join. Okay, so now first we have to create two tables. Okay, so after creating tables then we'll apply these joins. Okay, so first we'll create a department table. Okay, so if you want to create a department table, you need a data file, right? Okay, so username Cloudera, password Cloudera. Okay, so first we'll check department related data file, cd data ls cat dept.txt. Okay, so this data file I have few records. So first column department number and department name and then salary. Okay, so for this data we'll create one Hive table. Okay, so Hive table we have to create with three columns. Okay, so first we have to log in into Hive mode. Okay, so here we have to choose schema or database name. Okay, okay, database does not exist. Okay, show data basis. Okay, default December, October. Okay, let me create a database. Create database, then database name. Okay, so database created. Use database name. Okay, now I will create a department table. Okay, so create table dgt. First column name dgt number. Data type integer because only numbers. Second department name, so string data type. Next one salary int data type. Okay, so row format delimited. Here fields terminated by, so each column separated by which symbol, pipe symbol, so that we have to specify within single quotes or double quotes. Okay, so table successfully created. So here we can cross verify show tables. So department table it is showing. Okay, so table created but there is no data inside department table, so we have to load data. Okay, we have to load data. So here load data local in path. Okay, so data file is there in a local file system under home Cloudera under data directory dpt.txt. Okay, so this data file I am loading into dpt table. Okay, so successfully loaded. Now select from dept. Okay, so I have department table now. Department table contains a few records. Okay, so to apply joins we need one more table also. Okay, so we created only department table. Now we have to create a employee table also. Okay, so for that also we need the data file. So cat employee.txt. Okay, so here I have data. So for this also I will create a table. So create table, table name employee. So first column employee number, second column employee name, third column phone number. So phone number big int. Okay, then salary int. Last column department number int. So department column also we have common column department number. Employee table also we have common column department number. Okay. Row format delimited fields terminated by. Okay. Type symbol. Okay. So here also each row, each column separated by pipe symbol. Okay. If it is separated by comma, then we have to give comma. Okay. So table created. Now we have to load a data. Okay. So how to load here? We have to give employee.txt into which table? Employee table, right? This data file I want to load into employee table. Okay. So successfully loaded. Select star from employee. Employee table I have department number. Department table also I have department number. So one common column is there. So now we can apply joins. Okay. First we'll apply inner join. First. So select employee number name from which table? First table, employee table. Okay. So you are applying inner join. Inner join you are applying on which table? Second table, department. Okay. On from employee table based on which column? Department number column. Okay. And then from department table also department number. So wherever department numbers will match from both the tables, only those records it will populate. Okay. So now backend map reduce jobs are running. Job tracker executing map reduce jobs to retrieve the data from both the tables. So inner join only matched records, right? Employee table 21 is their department, okay? But department table here there is no 21, there is that is employee table, okay? So except 21 remaining all it should show. So here if you see from both the tables wherever department numbers matched, only those records populated. Okay, but a department table there is no 21 department number, so 21 department number not there in both the tables, that's why not populated. So inner join always wherever department numbers will match, only those records it will populate. Okay, so this is about inner join. Now left outer join. Okay, so here same query after table name left outer join. So employee table left side table, department table right side table. So now if we execute this query, employee table all the records it will populate, but opposite side table only matching records. Okay, so opposite side department, right? So department side matching means except 22 and 21 remaining all it will populate. Okay, because this 22 not there in employee table, department number 22. Okay, okay, I think only except 22 remaining all it will populate. Okay, because 22 not there in a left side table. So here if you see 22 not showing. Okay, 21 it will show because left side table all the records. Okay, so left side table all the records, but the right side table 22 is there, but that 22 not matching with left side table, that's why not populated. Okay, so this is about left outer join, and then right outer join. So right outer join means, so right outer join right side table all the records, that means now department table all the records 22 also it will populate, but left side table only matched records. So Right outer join. So right side table, all the records, even department number 22, 20, all the records populated. Okay. But left side table. Okay. Left side table, we have department number 21, but 21 not populated because 21 not there in department table. It is there in only employee table. So right outer join means right side table, all the records. Okay. But opposite side table only matched records. Okay. Next, full outer join. Okay. So full outer join means from both the tables, all the records. Now 22, 21 department related also it will populate data. 21 department also populated, 22 also populated because full outer join from both the tables, all the records. Now cross join. Okay. So cross join here just we have to specify cross. Okay. So for cross join we no need to apply condition. Okay. Select star from left side table name, then cross join, then right side table name. See 564 rows. Okay. If you see this 147 record from left side table. Okay. It is mapped with all the records from right side table. See, same 147. Again here same 147. This 147 record it is mapped with department number 18 row and again 17. So like that each row it will map with all the records from right side table. So this is about joins and next concept basic Hive functions. Okay, so basic Hive functions we have different concepts: mathematical, date, string, conditional, and aggregate functions. But in real-time projects, most of the people they are using only string functions and aggregate functions. Okay, so string functions we have again different functions. Okay, so length. So length means, for example, name is there. How many characters are there? Okay, 8 characters or 9. That length it will give. Okay. Concat means if you want to concat two different columns. Okay. So first name and last name. Okay. So both it will concat. It will apply merging. Okay. Substring means in for example, name is there. If you want only second position to only fifth position related characters. Okay. So specific position related means you have to use a substring. Okay. Upper means if you want to convert all the characters into uppercase letters, capital letters, then you can use upper. Lower means lowercase letters, all small letters it will display. Okay. Trim means before name or after name any space is there, then it will remove. L-trim means left side space it will remove. Okay, for example, one name is there, so before name left side if any space is there, then it will remove that space. And R-trim means right side space after word. Okay, and replace means instead of one character, if you want to replace with a different character, then you can use replace. Okay, so these are the string functions generally we'll use in real-time projects. And here I given queries also. Okay, so we'll see like how to apply these string functions. Okay, length, concatenation, substring, upper, lower. Okay, all this. Okay, so first we'll try length. So here select ename comma length of ename from employee table. Okay, so I want a employee name related length. See, this is employee name column. So length, how many characters? 5 characters. Here how many characters? 3 characters, like that. Okay, So this is about length. And same way, even you can use uppercase. See uppercase. This is the actual name, but it is converted into uppercase letters. Okay. Same way, even we can apply lower also. Lower. See here, B capital letter first, but it is converted into a lowercase a letter. Okay. And then concatenation. Okay. Concatenation means, for example, here one more column is there, phone number. Okay. So concatenation always we have to apply on two columns. Okay. So employee number comma phone number. Okay. So employee name, phone number. So both it is merged, right? Concatenation it is applied. Okay. So substring here, substring also built-in function. Okay. So substring of employee name, comma, which position to which position related characters you want. Starting position, ending position. Okay. So here you see. So here one, right? Okay. So one means K. And end position 3. Okay. 1, 2, 3. So 3 letters. Okay. So this is about substring. And trim and L trim. Okay. So right now we don't have any space. Okay. Okay. So to apply trim, we don't have any space between any words. Okay. Last one, replace. Okay. Reg exp underscore replace. So for replace, this is the built-in function. Okay. So replace, for example, capital K is there. Okay. Wherever capital K is there, you can put capital B. Okay. So capital K. So here capital K is there. It is replaced with capital B. Okay. But replace we have to use this built-in function. Okay. So you should not directly use replace. We have to use reg exp underscore replace and then which column related data. Okay. And which character you want to replace that character and a replace character. Okay. So this is about string functions. And the next aggregate functions. Okay. So aggregate functions means like sum. Sum means, for example, 10 employees are there. All the 10 employees related salary you have to apply sum. Okay. And the average salary. Okay. Minimum lowest salary, which employee is getting lowest salary. Max, which employee is getting a highest salary. Okay. So these aggregate functions also we'll see now. Select sum of salary. Okay. So backend again MapReduce jobs are running. Okay, because it has to apply sum, right? First it has to read all the employees related salary, total salary. Okay. So this is the total salary. And you can apply min and max also. Max means only highest highest salary it will populate. Okay. So which employee is taking highest salary? Okay, so 48,094 rupees highest salary. Same way, minimum salary, lowest maybe 5,000 or something it will populate. Okay, so lowest salary. And the average means, so all the employees' salary, first it will apply sum. Okay, so total salary by number of persons. Okay. So for example, if 1 lakh, okay, 1 lakh by 10 employees means by 10. So that average salary. Okay, so this is average. We'll discuss about these topics. Okay, first one is cluster by and distribute by. Okay, so basically cluster by and distribute by both are similar to order by and sort by. Okay, so here which one will give correct results means always cluster by will give correct results. Okay, and distribute by sometimes it will give wrong results. Okay, and group by, so how to apply uh, group by in Hive tables. Okay, on top of Hive tables, how to use a group by concept. Okay, and next topic that is how to create tables based on existing table. Okay, for example, you have a table, so that table contains 10 columns under data. Okay, maybe you want to create a duplicate table or backup table. Okay, so that time how to create a new table based on existing table. So next we have subqueries concept in Hive. So Hive is supporting subqueries also, that I will explain how to apply subqueries, how to create views and what is the purpose of views. Okay, and after creating again how to drop views. Okay, and what is the difference between a view and a table? Okay, so generally in interviews they will ask these kind of questions. Okay, difference between view and a table. Okay, also here we have union all and a union. So both these concepts Hive is supporting or not, that we'll discuss in this session. Also, we have some advanced concepts in a Hive, that is a partitioning and a bucketing concepts. Okay, so most of the real-time projects generally by default they will use this partitioning concept. Okay, so partitioning also we have two types of partitions. One is a static partition and the second one is a dynamic partition. Okay, and which scenario we have to use a static partition and which scenario we have to use dynamic partition, and what is the difference between partitioning and bucketing. Okay, so when we have to choose a bucketing concept and when we have to choose partitioning concept. Okay, cluster by and distribute by. Okay, first we'll discuss about distribute by. Okay, so distribute by, if you see, I have one table here. Okay, so table name T1. Okay, so my table contains this data. Okay, so cat, fish, dog, cat, dog, bird. Okay, so now when I apply distribute by, okay, so generally to apply distribute by, it is similar to your order by and sort by. Okay, so select star from table name T1 and distribute by on a specific column. Okay, so here this table related data, here are two reducers involved. Okay, so half of the data it went to first reducer and the remaining half of the data it went to second reducer. Okay, so when you apply distribute by, so obviously distribute by here it will not give correct sorting results. Okay, because here two reducers involved. On top of two reducers, generally it should apply sorting logic. Okay, but here it is applying on individual reducers. That's why here if you see final output wrong results. Okay, see first if you see order means sorting order, first it should come B, right? So bad it should come, after B C, then D, then F. Okay, so distribute by, whenever multiple reducers will involve backend, that time it will give false results. Okay, but if a single reducer involved means it will give correct results. Okay, so here we have cluster by also. Cluster by always it will give correct results. Okay, because here also if you see, I have T1 table, two reducers involved. Okay, so final results cluster by always it will apply on top of all the reducers. Okay, so on top of all the reducers data means, see here which one barred. Okay, so here always final results it is showing in sorting order. So barred, cat, cat, dog, dog, finish. That means cluster by always it will apply on top of all the reducers related data. It will not apply individual reducers. Okay, so if you compare distribute by and cluster by, which one will give correct results means cluster by will give correct results always. Okay, so distribute by it will give wrong results. So order by and sort by, if you compare which one will give correct results means order by will give always a correct result. So sort by it will give false results. Okay, so this is about cluster by and distribute by. Okay, so next we'll see how to apply a grouping. Okay, so till now we have not used any group by keyword. Okay, so for example I have one table, employee table. Okay, so my employee table department number column is there. Okay, so each department few employees are there, like department 10 maybe 5 members, department 20 5 members. Okay, so I want to know each department how many employees are there. Okay, so whenever you want to apply these kind of conditions, then you have to use group by. So group by column name, group by department number means it will apply group on department number column. Okay, so for that we have to write one query here. So here I have, I'm in a Hive mode. Okay, so here select star from maybe employee table. Okay, so employee table I have department number column. Okay, so if I apply group by department means department 21 how many records it should give? 4 records. 4 members are there with department 21. Okay, so 20 also 4 members. Like that each department it has to give results. Okay, so now select department number. Okay, count of star from which table? Employee table. Okay, so group by you are applying on based on which column? Department number column. Okay, so each department wise how many employees are there, that count it will give. Okay, so backend here map reduce jobs are running. So map reduce jobs will fetch your data from data nodes, and based on your condition, your query, it will fetch the results. Okay, so mapper 100% executed, reduced also. So department number 10, it is telling 3 records. Okay, so department number 10, 3 records. So even you can cross verify here. Cloudera cd data cat employee.txt. Okay, so department number 10, how many records are there with the department 10? Okay, so here only 3 records. So department number 3 and department number 11 4. So same results it is showing. Okay, so like this we have to apply a group by concept whenever it is required. Okay, so next concept, how to create a table based on existing table. Okay, so maybe if you want to take backup one table, okay, with the data columns everything. Okay, so that time you can create a table based on existing table. So here Hive, right? Okay. So create table. Table name I'm just writing a backup table. Okay. So based on which table you want to create new table based on employee table. Select star from employee table. Okay. Okay. So while creating table, you can create a table based on specific columns also. So here we given select star from. Star means all the columns related data. Okay. But instead of star, if you specify only employee name comma employee number, only those two columns it will create, and those two columns related data only it will import. Okay. So now we have to verify, right, backup table created or not. Okay. So here show tables. So backup table name showing. So that means it is created. Select star from backup. Okay. So based on existing table, we created a backup table. Okay. So here even if you don't want all the columns, okay, if you want only specific columns in a new table, okay, or specific columns related data only required in new table means you can specify only those columns. So employee number, e name only I want in a new table. Okay. So backup underscore new. So now backup underscore new table, it will contains only two columns, employee number and e name. Only those two columns related data it will import from employee table to backup underscore new table. Okay. So now we'll cross verify show tables. So here it is created backup underscore new table. Okay. So select a star from backup underscore new. See, only two columns related data I imported. Okay. So like this we can create new tables based on existing table. Okay. So next concept subqueries. Okay. Next concept subqueries. So subqueries means generally query inside one more query, that is called subquery. Query, main query, inside that query again subquery. Okay. So here if we see select a star from, okay, table name employee, where employee number greater than 130. That means 130 employee number 130 above related records it will fetch. Okay. And here again subquery is there. Select star from employee, order by salary descending. So that means highest salary first it will show, then lowest salary. So first I will write main query, select star from employee, where employee number greater than 130. Okay. So this is main query. Inside this main query we can write a subquery also. Okay. So here we can write, okay, select star from employee, order by salary descending. Okay. Order by salary descending. So basically first it will execute a subquery, then it will execute main query. Okay. So results are retrieved. Okay. So descending order, so highest salary, then lowest salary. And one more condition, employee number greater than 130. So here if you see 130 above related only employees details populated. Okay. So that is called subqueries. Okay. And next how to create views and how to drop views. Okay. Next concept. Okay. So generally, if you want to create views, you need a table. Okay. So views, it will read the data from table. Okay. Only runtime, whenever you will execute a view, immediately it will read the data from table and it will populate. Okay. So while creating view, generally why people will create views means, for example, if you are working for customer care. Okay. So for customer care people, generally they want to hide a password, maybe banking login password they want to hide, right? Okay. If table means all the columns related data, by default it will be visible. Okay. So if table contains 10 columns, okay, what they will do generally on top of table they will create view. So only required columns with required columns they will create view. Okay. So they will hide password column. Okay. So whenever some security or something they want to hide, only few columns related access if they want to give, then they will create these views. Okay. So views always read only. Okay. So now we'll see practically, we'll create one view. Okay. So if you want to create a view, you need table. So select star from maybe um, employee number, comma, employee name from employee table. Okay. So for create a view, or view name emp underscore view. Okay. So this view based on this table I'm creating. Okay. From this table only these two columns related. Okay. So a view created. If you want to see data, select star from emp underscore view. Okay. So employee table contains 5 columns. Okay. But we given access to only 2 columns. So these 2 columns related they can able to see. Okay. So views basically in select query you can write anything. You can write where condition or you can write joins. So whatever results this select query it will fetch. Okay. Only that results it will show for this view. Okay. Now how to drop a view? So drop view, view name emp underscore view. Okay. So whenever you want to drop. Okay. So here show table, see emp view not showing, successfully dropped. Okay. So this is about views. Okay. Now what is the difference between a view and a table? Okay. Difference between a view and a table. So basically these kind of questions they will ask in interviews for 2 years or 3 years experience people or freshers. Okay. So view without table, view creation not possible. Okay. Without table, view creation not possible. But without view, table creation possible. You can create table without view, but without table, view creation not possible. And when view holds the data means only runtime. Whenever you are executing view, that time only it holds the data. Once a view execution completed means generally it doesn't hold any data, because data always available in a table only. But when you are executing view, that time backend it will connect with your table. From there it will read data. Okay. And there is no space wastage in views generally, but a table sometimes a space wastage will be there. Okay. So that is about views. Okay. So next concept union and union null. Okay. So in SQL we have union also. Okay. So union it is supporting in SQL, but in a Hive union are not supporting. Okay, so here only union all it is supporting. Okay, so basically union all whenever you want to read data from multiple tables, at the time you have to use union all. Okay, so at a time you want to read the data from two tables, then you can use union all. Select star from employee. So this is one table. Then union all. Then your second table. So select the star from. Maybe I'm giving a backup table. Okay. So union all. So when you are writing select query between those two tables, you have to specify union all. Okay. Then from both the tables, all the records it will populate. See 94 records. Okay. So this is your second table data. Okay. So this is 101 to 147 second table. This is your first table data. Okay. So here only union all it is supporting, but the union doesn't support in Hive. Okay. So this is about union all. Okay, so next concept partitioning and bucketing. Okay, so this is a important concept in a Hive, partitioning and bucketing. Okay, so first we'll discuss about partitioning. Okay, so here partitions we have again two types of partitions. Okay, static partition and a dynamic partition. First of all, what is the use of partitioning? Okay, for example, when you create a table, backend generally in HDFS, it will create a directory like this, right? So Cloudera and table name. Okay, under this table, your data file. So from here, basically your select query will read data. So for example, here you are applying some where condition. Okay, where, okay, month equal to John. Okay, that means this select query has to scan all the records. In that it has to filter out only January month related data. So that means it has to scan all the records. Okay, if data is there in terabytes or petabytes, it will take more time, right, to scan your data, so performance will decrease. Okay, that's why they introduced partitioning concept. Okay, so partitioning generally what it will do, okay, under this directory here again it will create a sub partition. Okay, so January, so January means January month data here. Okay, so again here February. Okay, so here February related data. So like that it will create n number of partitions. Okay, so what is the use means, when you apply where condition, directly it will go to this directory. So no need to scan data blindly, it will fetch your data and it will show here. That means performance will be very fast. Okay, so partitions basically you can apply day wise also, okay, month wise also you can apply. Okay, and even hourly also you can apply, like first hour, whatever data will come first hour it will move. Okay, and daily means a date wise partition. Okay, with the 12th date one partition, whatever data it will come today, under that date it will push your data. And month means each month related. Okay, and again yearly, yearly also you can apply partition. So 2021 related entire data under one partition. Okay, so partitions basically you can apply on hourly basis or day wise you can apply, and same time monthly also you can apply. Okay, and yearly also you can apply. Okay, now we'll see first static partition. Okay, and then we'll see dynamic partition. So difference we'll discuss later. First we'll see practically. Okay, so to apply a static partition, here I have data files. 2011 related data is there, and 2012 related data is there, and 2013 related data is there. Okay, so for this data I will create first static partition. Okay, so for that first we have to create a table, and then we have to load data into table. Okay, okay, so here total 3 columns. Okay, so student name, student number, student passed out year. Okay, student passed out here. So for this data we have to create a table. For this data we have to create a table. Okay, so here create table. Okay, so static underscore partition. Okay, so first column student name string, second column student number. Okay, so partition we are applying on a year column. Okay, so year wise. Okay, so here partition of, so partition you are applying on which column, that column we have to specify here. Okay, so student passed out year. Okay, so data type int. Okay, int, then here row format delimited fields terminated by. Okay, so here data separated by each column comma. Now partitioned by. Okay, so partitioned by. Okay, so here we have to use so create table name, first column student name, then data type, then student number, data type, then partitioned by. Okay, and then column name. Okay, and then data type. Okay, so if you want to apply, in case if your data contains month, here you have to specify month, column name and data type. So partition by you are applying on a date means maybe date column name. Okay, like that. So now we have to load the data into table. Okay, so our data is there under this directory. Okay, under local directory. Okay, so here data is there under that directory. So static underscore partition underscore details underscore 2013. Okay, 2013 dot txt. Okay, so into table, which table you want to insert this data? So table name we know, right? Static underscore partition table. So here while inserting we have to specify which year related data we are passing. Your data file contains which year related data. Okay, so here if you see 2013. Okay, 2013 related here partition of. So which year related data you are passing, that year you have to specify. Okay, so here into table S year equal to 2013. Your data file contains 2013 related data. Okay, so here partition keyword also we have to specify semicolon. Okay, so successfully loaded 2013 data. Okay, so now if you see backend, okay, Hadoop fs -ls user hive warehouse. So backend it is created one partition or two partitions, that will check now. Okay, rr digital dot db. Under this your table name should be there. Okay, so table name static underscore partition. So here it is created 2013, it is created partition. Okay, so yes year equal to 2013. Okay, so we loaded only 13 related data, so that's why only one partition it is created under 13 related data available. Okay, now if you load 14 and 15 related data, okay, 11 and 12 data will load. That means 11 and 12 also it will create partitions. Okay, so here hive hive so 11. Okay, so data file name also 11.txt. Okay, so 11 related data loaded. Now again same table 12 year 12 related data also I am loading. Okay, so 12 related data also loaded. Now if you see backend, how many partitions available means 3 partitions. Okay, so 11 12 11 12 13. So in a hive, if you execute your query, okay, select star from static underscore partition where s year equal to 2013. Okay, so now no need to scan entire table related data like 11 12 partitions related data. So directly it will go to this directory backend. From there it will read your data. So performance it will give very fast. See here very less data, but in real time, so large data. Okay, so no need to scan. It will directly go to the directly that particular partition. It will fetch your data. So this is about static partition. Okay, so static partition when we have to use means whenever your data file contains a specific date related data, okay, or a specific month related data or specific year related data, then you have to use a static partition. Okay, dynamic partition when your data file contains mixed data. Mixed means maybe all the years data or all the months related data or maybe all the days related data. That time you have to use dynamic partition. Okay, so now we'll discuss about dynamic partition. Okay, so dynamic partition generally we have to follow some steps. Okay, so first we have to create one temp table. Okay, then load data into temp table. Okay, then create a dynamic partition table. Then load data from temp table to dynamic partition table. So these 4 steps we have to follow. But you have your data already there in some table means you can consider the table as a temp table. You no need to create again table and you no need to load a data. Okay. So, but the backend here, backend, we have to enable dynamic partition. Okay. So by default, dynamic partition will be there in a disable mode. Okay. So we have to enable that. Okay. So this command we have to use. Okay. So before creating tables, by default in your command prompt or cluster, dynamic partition, it will be disable mode. Okay. So we have to enable that. Okay. So Control C. So here your Hive mode, first you execute that command. Okay. So now we'll create a temp table. First step, temp table. Okay. So I have one data file. So the data file contains all the years related data. Okay. So 2009, 2010, 11. But earlier, each data file a specific year related. That's why we use a static partition. Okay. But now this data file contains multiple years related data. Okay. So first we'll create one temp table. We'll load data into temp table. Okay. Create table dynamic underscore temp table name. First column. Okay. First column student name string data type, then student number, then student passed out year. Okay. So this is like your normal internal table. Okay. Row format delimited fields terminated by. Okay. Comma. Okay. Table created. Now we have to load data into temp table. So load data local inpath. So data file is there under this directory. Okay. Home cloudera data std all dot txt. Okay. Into table, which table you want to insert this data, dynamic underscore temp table. Okay. So we'll cross verify data loaded or not. Select star from dynamic underscore temp. Okay. So whatever data is there in data file, so entire data loaded. Okay. So now first 2 points we completed. So temp table we created, we loaded data into temp table. Now we have to create a partition table. So here create table dynamic. Okay. And first column student name, student number. Okay. And partitioned by. Okay. So partition we are applying on which column? Year, passed out year column. Okay. And then row format delimited fields terminated by comma. Okay. Okay. So partition created as here. Now we have to load data from temp table to dynamic table. Okay. So here temp table select star from dynamic underscore temp table. Okay. So this data we have to load into. So insert into table. Which table? Dynamic table. So you want to insert into dynamic table. While inserting, you have to apply partition based on which column? Year column. Okay. So what it will do? It will read each record. If it is a 2010 means 2000 under 2010 partition, it will load. If it is 11, 11 partition like that. Okay. See here, it is created partitions. Okay, 2010, one partition, 11, 13. So 13 related data under 13 partition, 10 related data under 10 partition, like that. Okay, so now if you apply select query, select star from employee, where SCR equals to 2000, 10 means only 10 related data. Select not employee dynamic table, right? Okay, select star from dynamic, where SCR equal to 11 means only 11 related data. 12 means 12 related. So backend automatically it will create partitions. Okay, static partition, we have to specify which year related data we are loading. But a dynamic partition, you no need to tell, Hive will take care. Based on data, it will create partitions and it will load data. Okay, so this is about static and dynamic partitions. Okay,
We'll discuss about three topics.
so first one, bucketing. Second one, table sampling. Okay, third one, complex data types. Okay, data types. So first we'll discuss about first concept of bucketing. Okay, so why bucketing is required? Okay, so basically bucketing is similar to partitioning. Okay, so in the previous session we discussed about static partition and dynamic partition. Okay, so basically this partitioning and bucketing to improve query performance will use. Okay, so whenever we are trying to retrieve the data, it will give good performance if we use partitioning and bucketing. Okay, but already partitioning is there, so why we have to use again bucketing? Okay, generally most of the organizations, 90% projects, they are using only partitioning concept. Okay, so only 10% projects they are using a bucketing concept. Okay, so why bucketing came into picture means partitioning. We have one small drawback. Okay, so what is that drawback means? For example, okay, so when we create a Hive table, okay, so user Hive warehouse. So under this generally it will create a partition, right? Under this maybe table name. Under this table partition. Okay, partition means maybe with the 2021 one directory. Okay, so 2021 related data here. Okay, so same like maybe you can assume 100 partitions created. Okay, so 100 partitions means maybe 2020 also one more partition. So under 2020 year, whatever data generated 2020, so that data available. Okay, so here I have 1980 related partition. Okay, so 1980 I have very less number of records. So less number of records means you can assume only maybe 10 or 20 records. So you can assume last 50 years, each year I have more data, maybe uh, GBs and terabytes. Okay, but 1950 to 2000, 1952, maybe 1990, I have each year very less number of records. Okay, so each year maybe 10 records or 20 records. Okay, so if you have less number of records, okay, separate partition not required. Okay, so that means almost 50 years are related, 50 directories it will create, 50 partitions, but each partition you can assume only 10 or 20 records. Okay, so for less number of records, partitions not required. So whenever your data is large data, you are unable to scan. If it is taking more time, then only partitioning is required. Okay, but here whenever less number of records are there, at the time if you use a partition, there is no use. Okay, so I can club these 50 partitions, right? 1950 to 1990. Okay, so due to that small drawback in partitions, bucketing came into picture. Okay, so here basically bucketing, okay, partitioning always that is a Hive control. Okay, your Hive framework will take care how many number of partitions it has to create based on data. It will be control. But here bucketing always it is a user control. User control means you can decide your data you want to keep in how many buckets. Okay, so maybe you have 1 lakh records. Okay, so here table name. Okay, so bucket 1. Okay, maybe here 50k records it will place. Okay, and the remaining 50k maybe another bucket under same table only different bucket. Okay, so while defining a table, while defining a bucketing table, you have to specify your data you want to keep in how many buckets, whether 2 buckets or 3 buckets or 4 buckets. Okay, so here for example create table emp. Okay, so generally here we'll write column names, table names. Okay, maybe department number like this, right? After that here clustered by, so bucketing you want to apply based on which column. Okay, so that column name. Okay, so into how many buckets your data you want to put into how many buckets. Okay, 3 buckets. Okay, so that means your entire data it will keep in only 3 buckets. Okay, but partitioning based on your data it will create n number of partitions. Okay, 2020 one partition, 21 one partition, or if it is a device partition means with the today date one partition, tomorrow date one more, or yesterday date. Okay, like that. Okay, create bucketing table we have to follow some steps. Okay, so basically backend bucketing concept will be in disable mode. So we have to enable that bucketing concept. Okay, for that we have to execute one hive command. Okay, so set hive dot enforce dot bucketing equals to true. So this is the command you have to execute in a hive mode, so that backend it will enable a bucketing concept. Like partitions also we executed one command, right? Similarly here also we have to execute this command. Okay, and second you have to create a table, temp table. Okay, and you have to load data into temp table. Okay, already if your data is there in some table, you no need to create step 2 and step 3. Okay, and then fourth step, create a bucketing table, bucketing table. And the fifth one, insert data into bucketing table from temp. Okay, so these are the 5 steps we have to follow while creating bucketing. Okay, so now practically we'll see. Okay, so here I have to choose the database, use RR digital, show tables. Okay, so here select a star from employee. Okay, so employee table 47 records. Okay, so this employee table I am considering as temporary table. Okay, so that means no need to create again table. Okay, so second and the third step completed. I have a table, inside table already data available. Now I will execute this command. So set hive dot enforce dot bucketing equals to true. Okay, so now bucketing concept enabled backend. Okay, so now step 4, I have to create a bucketing table. Okay, so I know my temp table contains how many columns? 5 columns. Okay, so bucketing table create table emp underscore bucket, my table name. Okay, so first column, second column, and then third column, and salary department number clustered by, so based on which column? Okay, department number column, so clustered by department number column, and then you want to create how many buckets? Okay, into 3 buckets. Okay, and then row format delimited fields terminated by. Okay, so data separated by, here I am giving a pipe symbol. Okay, so bucketing table created. Okay, show tables. So here emp underscore bucket. Okay, so now fifth step, insert data into bucketing table from temp table. Okay, so here insert into table emp underscore bucket. Okay, so data we have to insert into emp underscore bucket table from which table? Select star from employee table. So whatever data is there in employee table, same data you can insert into bucketing table. While inserting, you can put data into 3 buckets. So here backend MapReduce jobs are running. Okay, so now we'll verify. Okay, so select star from emp underscore bucket. Okay, so whatever data available in temp table, now same data available here. Okay, but we have to check, right, data available in 3 buckets, backend it is created 3 buckets or not. Okay, that we have to verify. Okay, so we'll see how many buckets it is created. Okay, so Hadoop fs-ls user hive warehouse under warehouse database name. Okay, or digital under that emp underscore bucket. So under db name table name emp underscore bucket directory. Okay, so total 3 buckets it is showing, right? Okay, so this is first bucket, this is second bucket, this is third bucket. Okay, so your data available in 3 buckets. Okay, so partitioning means generally date wise or month wise, but here user can decide if you want to put your data into only 2 directories, you can put. If you want to put your data into 3 directories, you can specify into 3 buckets or 5 buckets or 10 buckets like that. Okay, but here when we execute your table name, all the buckets related data it will populate. But now question is how to retrieve a specific bucket related data. So I have 3 buckets backend, but I want only first bucket related data, or I want a second bucket related data. So how to check that? So for that, here we have one more concept. Okay, that is a table sampling. Okay, so table sampling we have 2 options. Okay, one based on bucket you can retrieve your data. Okay, second option percentage wise also you can retrieve your data. Okay, like maybe you want 20% data from all the buckets, or maybe 70% data from all the buckets. Okay, so practically we'll see this table sampling concept. Okay, so now here mp underscore bucket, so table sample of bucket 1 out of 3. I have total 3 buckets, but I am telling here you can retrieve only first bucket related data. See, first bucket related only 16 rows. We have total 47 records. Okay, so now if you want only second bucket related data, then 2 out of 3. Again 15 records. Previously 16 rows, now 15 rows. And then 3 out of 3. 16. So 16 plus 16, 32. 32 plus 15, 47 records. Okay, so whenever you want to retrieve specific bucket related data means, then you have to use this table sample concept. Okay, so number of buckets 3 means 3. If number of buckets 10 means, you have to specify 10. So out of 10, which bucket related data you want? If it is a fifth bucket related means fifth. If it is third means third. Okay, but a space compulsory we have to give. Okay, so this is about a table sample. So table sample, again here we have percentage wise also we can retrieve, right? So now how to retrieve data based on percentage. Okay, so I have data in 3 buckets. Okay, but from all the buckets I want to retrieve maybe 10% data. Or maybe from all the buckets I want to retrieve 100% data. Okay, then we can use a percentage wise also. See, 47 records. Okay, so here if you want 10%, if you want a 50% data from all the buckets, then you can retrieve percentage wise. Or if you want to specific bucket related means bucket 1 out of 3, bucket 2 out of 3, like that we have to specify. Okay, so this is about table sampling. Now we'll discuss about complex data types. Okay, so in Hive we have different data types, right? Integer, varchar, string, boolean, float. Okay, so along with those data types, here we have complex data types. Okay, so complex data types, so first one is array. Okay, second one is map, and third one is struct. Okay, so we have total 3 complex data types: array, map, struct. Okay, so these 3 data types are important. Okay, same time when we have to use array data type, see, we know when we have to apply string data type. Okay, and we know when we have to apply integer data type, but array data type when we have to use. Okay, so for example here I have 3 columns. Okay, name, employee number, and then subjects. Okay, so subjects means basically this BSc or BTech people, they will choose a stream, right? CSC or ECE. Okay, stream. Okay, so here stream like computers. Okay, and chemistry. Okay, and physics. Okay, so this is collection of data. Okay, column name is a single column, but it contains multiple values. Okay, So whenever in your data file contains a specific column contains a collection of elements, at the time you have to use array data type. Okay, and now coming to map. So map, whenever you have data in a key comma value pair, at the time you have to use a map data type. So key comma value pair means, for example, employee number, e-name. Okay, after that I have like this salary, maybe salary 2000 rupees. Okay, and then here bonus, okay, 200 rupees. That means this is key, this is value. Again, this is key, this is value. So whenever your data file or specific column contains data key value pair format means then you have to use map data type. Okay, and then a struct data type. Okay, so this struct data type generally whenever address kind of data is there, then people will use a struct data type. Address means here maybe street number, okay, area, then pin code. Okay, so whenever these kind of like here you have to use multiple data types, right? Integer, string, and again int. Okay, okay, so whenever your data looks like a address kind of, then you have to use a struct data type. Okay, so now practically we'll see how to use all these three data types. Okay, so here I have data files, small data sets, ls, at. So okay, so here I have one small data file. So this is student name, okay, and the student marks, and this is a subjects or stream, okay, and this is a grade. Okay, so now I have to create a table and I have to load data. While creating a table, I have to use array data type for this column. Okay, so now Hive mode. So here I will create table, internal table, create table, table name student underscore array. First column student number. Okay, second column student marks are passed out here. Okay, and the next column name may be subjects, right? Subjects are stream. Okay, so here data type array. Okay, but maths, physics, chemistry, which data type? String data type. Okay, and then grade, ABC grade. Okay, so grade I am giving a string. Okay, so here row format delimited fields terminated by, so between each column data separated by comma, but here maths, physics, chemistry separated by dollar symbol. That means a collection of items. Okay, so collection items terminated by which symbol? Dollar. Okay, so basically this array data type came from Java. Okay, this is there in Java. Okay, so array means a collection of elements or collection of values. Okay, so here collection items terminated by which symbol means a dollar symbol. Okay, and each column separated by which symbol means comma. Okay, so table created. Now I have to load data, right? So load data local in path. So my data is there under this directory. Okay. Home Cloudera data array data file dot txt into table. So this data file you want to load into which table? Student underscore array table. Successfully loaded. Okay. Now select from student underscore array. Okay. So successfully loaded data. But now if you give select star from means all the columns. But in the third column name we know subjects. Okay. I want only first position related data. Okay. So here column name subjects, right? Subjects of 0. Okay, here position starts from 0. See, maths, biology, civics. So maths, biology, civics. And even first column also if you want means here student name. Okay, student name. And if you want again subjects, third position related means here instead of 0, 2. Okay, so chemistry, commerce. Okay, so like this you can retrieve your data for array data types. Okay, so this is about array. Now we'll see map. Okay, so for this also we need a data file ls cat map data file. Okay, so here also I have small data file. See, this looks like employee number. Okay, this column, this is employee name, but this looks like payments. Okay, so third column looks like a key value, again key value, key value. That means for this column we have to apply map data type. So here create table emp underscore map table name, employee number, employee name. Okay, so last column name payments. Okay, and which data type? Map data type. So salary, commission, bonus, these three keys, and 5,500 100 values, key value. So keys, all the keys is there in a string. Okay, and the values int. Okay, in row format delimited fields terminated by your data separated by comma. Okay, so here between each key value what is there has a symbol. Okay, so that is called collection items terminated by which symbol has. Okay, but this key value pair, which symbol it is separated? Dollar. For that map is terminated by dollar. Okay, so now table created, we have to load a data file, right? Okay, we have to load a data file. Okay, so table name emp underscore map. Okay, your data file name map data file dot txt. Okay, so this data file we are loading into emp underscore map table. Okay, show tables. So emp underscore map table created. Okay, and data loaded or not will cross verify from emp underscore map. Okay, so data loaded, this is key, this is value. Okay, but now how to retrieve a specific key related value. Okay. So third one, payments, right? Column name payments. Payments of which key related value you want. I want a salary key related value. See, 5,000, 6,000. If you want only bonus related, here bonus. Okay, so like this we have to retrieve the data. Okay, so this is about map. And the next struct data type. Okay, struct data type, data file required ls. Okay, so cat and then struct data file. Okay, okay, so in this data file, for this column we have to apply array, and for this we have to apply map, and for this we have to apply struct data type. So all three complex data types we have to use now. Okay, so here create table, employee, create table name emp underscore struct, employee number, employee name, array. Now first column name, right? Subjects. For subjects, array data type, and massive physics chemistry characters, so string. Okay, and then payments. For payments, which data type? Map data type. So all the keys characters, the values, so integers. And then the last one, address column, because Bangalore, Karnataka. Okay, so address we have to apply struct. Okay, so first one, city, string data type. Second one, state, string only. Third one, pin code, int. Okay, so now row format, delimited fields, terminated by, so each column separated by comma, and the collection items terminated by, so here massive physics chemistry separated by dollar. Okay, so here also between key value pair, each key value pair dollar symbol is there. That means here dollar. Okay, and the map is terminated by hash. Okay, so now I will load data, local in path, so home Cloudera data struct data file dot txt into table. You want to insert this data into which table? emp underscore struct. Okay, so data successfully loaded. Now we have to cross verify, right? Select a star from emp underscore struct. Okay, so now we know array related data how to retrieve. We know map related data how to retrieve. Now we'll see how to retrieve only struct related data, struct data type related data. Okay, so here, so for example, I want only state related value. Okay, so here address dot state, see state name, and if you want to pin code, here pin code. Okay, so this is about complex data types. Okay, so complex data types and bucketing, table sample, these all are important concepts. Okay, discuss about advanced Hive features. Okay, so in advanced Hive features, we have two topics. Okay, so here we have two concepts. One is Hive scripts. Okay, second one is parameters passing. Okay, so here first we'll discuss about Hive scripts. Okay, so why we have to implement Hive scripts and how to execute Hive scripts. Okay, so basically in a real time based on requirement we have to implement a n number of queries. Okay, so till now each concept individual queries we executed. Okay, but in a real time based on a requirement we have to implement a n number of queries. Okay, so like query 1, query 2, query 3, like this. So all these n number of queries we have to put into one script. Okay, so that script it should ends with HQL dot HQL. So script name you can give any name. Okay, like generally in real time we have to give meaningful name. Okay, if it is customer data, customer dot HQL. If it is employee data, employee dot HQL, like that. Okay, so Hive script always it should ends with dot HQL. Okay, so here why people are calling HQL. Okay, so basically we have SQL. Okay, so SQL generally will call structured query language. Okay, so similar way here also we are using a queries only. Okay, but where we are using means Hive. Okay, so this basically we have to call Hive query language. Okay, so this is the full abbreviation for HQL. Okay, Hive query language. Okay, and you can call Hive query language or else directly you can call HQL. Okay, so whenever you will implement any kind of script, that script should ends with dot HQL. Okay, so now we'll implement one small Hive script. Okay, so how to implement that? Okay, so now you can assume I have one requirement from a client. Okay, so maybe first client told me to create one table. Okay, after that we have to load data into table. Okay, after that maybe we have to apply some business logic. Okay, maybe business logic means here I'm just assuming where salary greater than something. Okay, and fourth step I have to save this final data into uh, another table. Maybe you can assume this data we have to store into final table. Okay, so this is a small requirement. Okay, but in real time generally it will be big requirement. Based on requirement we have to implement a number of queries. Okay, so here first we have to create a table, right? Okay, so to create table here we have to write a create statement. Okay, so create a table. Okay, maybe emp. Okay, employee number. Okay, string data type, and then phone number big int, then salary int. Okay, then department number. Okay, so row format delimited, fields terminated by a pipe symbol, data separated by pipe. Okay, so this is your first requirement related query. Okay, And next I have to load the data into table. Which table? This EMP table. Okay, so here load data local in path. See, if your data is there in a HDFS, you can give HDFS path, then local command not required. Okay, but my data is there in a local file system. Okay, so here data file is there under this path. Okay, home cloudera data, then employee.txt. Okay, into table. Which table you want to load this data? EMP table. Okay, so based on requirement, a second query also I implemented. Now I have to apply a business logic. So where condition. Okay, so select star from EMP where salary greater than 40,000. Okay, so third query also I implemented. Okay, now whatever results this table, this query will give, that results I want to store into another final table. Okay, so create table emp underscore final. Okay, yes, this query. Okay, so whatever final data it will retrieve, with that I'm creating one table. So this table, it should be final results. Okay, this table should contain final results. Okay, so all these 4 steps I implemented. Now I'm copying this all the 4 queries, control C. Okay, so here maybe uh, control L. Okay, so here we have to create a HQL script. Okay, so cat greater than sample.hql. So here I copied all the 4 queries. Okay, and then control C. Okay, now my sample.hql file created successfully. Okay, so you can cross verify here sample.hql file. So if you want to verify content saved or not, then cat sample.hql. Okay, hql. So in real time, based on requirement, you can implement n number of queries. All those n number of queries we have to place inside a HQL file. Okay. Now, if I execute this HQL file, all the queries will execute. Okay. So first it will execute first query, then it will go to second query, then third query, like that. Okay. So how to execute a HQL file? Here Hive -f, then HQL file name sample.hql. So this is the command which will execute your Hive scripts. Okay, so here table created, after that load command executed. Okay, so where it is created means a default database or default queue. Okay, and now final table, it is creating a final table. Okay, so backend map reduce jobs are running. So database name we have not given. Okay, that's why by default it is selected default database. Okay, so now here Hive mode. So use default database. So here we'll verify final table created or not. Okay, so final table name emp underscore final. Select star from emp underscore final. Okay. So business logic we applied this only, right? Salary greater than 40,000 related data. Okay. Like this in real time we have to create Hive scripts, HQL scripts, and we have to execute. Okay. And the next concept, how to pass parameters to HQL scripts. So here, if you see, I have created a table name with EMP. Okay. But again, if you execute the same HQL script, it will not execute. It will throw error, right? A table already existed error will get. Okay. And here also, if you see, today my data separated by pipe symbol. Okay. So that means this SQL will execute. Okay, it will work. But tomorrow, my data maybe it will come with comma separated. So at the time, if we execute this SQL file, it will throw error. It will not work. Okay, so that's why basically we have to define parameters wherever it is required. We have to define parameters while executing the HQL file. We have to pass those values, those parameters related values. Okay, so here instead of hard coding table name, I will define a parameter here. Okay, so here dollar, so table name. Okay, so here hive where this is my parameter name, and here also you can define a parameter. So dollar hive conf for variable, you can give basically anything. Okay, hive conf for variable, and here delimited. Okay, delimited. Okay, so even here also if you want you can define parameter. So wherever you need any parameter you can define. Okay, so now these two statements, okay, these two statements I will keep in one HQL script and I will execute. Okay, so here cat greater than parameter passing data HQL, okay, and paste. So ls parameter passing. Okay, so cat parameter passing dot HQL. Okay, so now this is one parameter, this is another parameter. Okay, so while calling this HQL script I have to pass values. Okay, so hive hyphen f and then parameter passing dot HQL. Okay, so before hyphen f here we have to specify parameter. So first parameter name this one hive where hive where, okay, table name equal to. Okay, so maybe table name I want to specify emp1. Okay, and then next parameter name, here hive conf. Okay, hive conf delimited equals to. Okay, so if your data separated by comma means comma, dollar means dollar. Okay, so here type symbol. Okay, then semicolon. Okay, okay, so while running the script we are passing the parameters. Okay, so now we'll cross verify here table created or not, show tables. So table name emp1, so emp1 successfully created. Select star from emp. Okay, so like this we have to pass parameters to hive scripts. Okay, so even database name also. Okay, so database name also you can create. Okay, so here we have to specify, right, use database name. Okay, so here also if you want you can pass a parameter. Okay, so hive variable or conf you can give, okay, like this. So this is about hive scripts and parameter passing. I will discuss about DML commands. So basically in hive 0.12.0, okay, so initial versions DML commands not supported in Hive. Okay, but after 14.0 version onwards, Hive is supporting DML commands. Okay, so DML commands means basically insert, like in SQL we are using, right? Okay, insert, update, and delete. Okay. So to enable these DML commands, basically backend, we have to add a few set commands in properties file. Okay, so in real time, basically Hadoop admin team will add those properties. Okay, so here, so these all are the properties we have to add in a hive-site.xml file. Okay, so if we add these properties, then only it will support DML commands. Okay, like insert, update, delete queries. Okay, or else we have to add these set commands. Okay, but performance will be very less. Okay, so because Hive is supporting update, delete, but still it will give a very less performance. Okay, also in a real time, these properties Hadoop admin team will take care. Okay, in a few projects they are enabling this DML commands, but a few projects they are not enabling. Okay, due to performance issues. So here we'll add these properties. Okay, and we'll try how to execute DML commands. Okay, so to execute the DML commands, first we have to enable these concepts in backend. Okay, so these all are the properties. Okay, we have to add. Okay, so where we have to add means inside a hive-site dot XML file. Okay, so basically these properties, these things Hadoop admin will take care. Okay, but here just knowledge purpose we are discussing. Okay, where we have to add, how to add. Okay, so to add these properties, we have to log in into root user. Okay, root user. Okay, so here root and password Cloudera. Okay, so here we have to go to Hive directory. Okay, so cd slash usr ls, so cd lib ls. Okay, so here all the Hadoop related softwares they installed. Okay, so like a Hive model related they installed here, and pig model related, Wooji related. Okay, so basically in real time in a Hadoop we have many models. Okay, 8 to 10 models, but if they are using only 3 models, 3 components, then no need to install other components, right? Only required components. Okay, so here only required components generally they will install in the real-time projects. Okay, so now here I have to choose Hive directory. Okay, cd Hive. Okay, ls. So here conf folder. Okay, so inside this conf folder we have all the XML files. Okay, configuration related XML files. So cd conf. Okay, again pwd. Okay, ls. Okay, so here your hive-site.xml file available. Okay, so inside this XML file we have to write those properties, or we have to add. Okay, so to modify this XML file we have to use a vi command, right? So vi hive-site.xml. Okay, and insert mode, now I entered into insert mode. Okay, so I will add these properties at the end. Okay, so maybe here I will add. Okay, so properties I copied already. Okay, then escape colon WQ. That means it will save and it will come out. Okay. So now we'll cross verify whether those properties are saved or not. Okay. Hive site.xml. Okay. So here all the properties are saved. Okay. So now we have to restart a Hive server. Then only these properties will enable backend. Okay, so changes will reflect once we restart Hive server. So this is the command. Okay, so in real time, basically Hadoop admin team will execute these restart commands. Okay, so here, so Hive server stopped, and again server restarted. Okay, now we have to close this root user window, and this window also I am closing. Okay, so I am opening uh, we have to open a new window. Okay, so here Cloudera, username Cloudera, password Cloudera. Okay, so now I'm logging into Hive mode. Okay, because DML commands we have to execute in a Hive. Successfully logged in. Show databases. Okay, so here default database is there. Okay, so use default database. Okay, so generally we can call as a database, or we can call as a queue also, queue. Okay, so show tables. There are no tables. Okay, so now first we'll create a table. So create table name I'm giving a customer. Okay, so here CID means customer ID. Okay, and customer name. Okay, here I'm giving a varchar of 129. Okay, and then clustered by. Okay, so based on which column, we have to insert. Okay, based on CID. Okay, into how many buckets? Here I am giving 2 buckets. Okay, so 2 buckets, and then stored as ORC. Okay, so whenever we want to execute DML commands, we have to specify stored as ORC. Okay, then TBL properties, that means table properties, transactional equals to true. Okay. So this is built-in function, TBL properties. Transactional equals to true means generally it will allow to execute update queries. Okay, update and delete queries. Okay, now table created, so we'll insert data insert. Okay, so insert into customer values. Okay, so first column ID, so ID value I am passing as 1. Okay, second one customer name. Okay, I am passing as Ram. Okay, okay, so now select star from customer. Okay, so data inserted successfully. Okay, and the next one update. Okay, so update table name customer. Okay, set which column related value you want to update. So okay, so instead of Ram I want to update Sam, where ID equals to 1, where CID. Okay, where CID equals to 1. So instead of Ram, we are updating Sam. Okay, so now we'll cross verify record updated or not. Okay, so instead of Ram, Sam replaced, so successfully updated. Okay, and the last one delete. Okay, So if you want to delete data from table, okay, delete from which table? Customer table. Okay, so now we'll verify that data removed or not. Okay, successfully deleted. So this is about DML commands. Okay, so next concept, the file formats. Okay, so in Hive is supporting different types of file formats. Okay, so one is a text file format and RC file format and ORC file format and Parquet file format and Avro and sequence file format. Okay, so while creating a table, so file formats. Okay, so here uh, basically we'll create a table like this, right? Okay, so create table, maybe uh, table name. Okay, and then here column 1, column 2. Okay, like this n number of columns. Okay, after that row format delimited fields terminated by. Okay, so maybe if it is comma comma. Okay, so generally in Hive we will use create statements like this. Okay, so here we are not specifying any file format. Okay, so if we not specifying file format, that means by default it will consider as a text file format. Text file format. So if we not specify means by default it will consider text file format. Okay, and how to define file formats in a table. Okay, so end of your create statement you have to specify stored as text. Okay, if it is text file format, stored as text. If it is VRC means stored as VRC. Okay, if it is a Parquet means stored as a Parquet. Like this we have to specify. Okay, so only these three keywords backend your Hive framework will execute based on these three keywords. Okay, so just end of your create statement you have to specify file format. If you not specify, then by default it will consider text file format. Okay, or else you can specify like RC or ORC, whatever. Okay, so except this you no need to write anything. Okay, but what is the use of uh, these file formats? Okay, first point, it will save your HDFS space. Okay, because file formats, basically few file formats, it will compress your data. Okay, like generally in Windows operating system, if you have one folder, will do zip, right? Zip means actual size 1 TB means it will reduce after zip. Okay, so same way here also it will apply compression techniques so that it will save space. Okay, and retrieval also it will be very fast, speed retrieval. Okay, see, obviously if data it is compressing and size will be reduced means performance will give very fast, retrieval is very fast. Okay, and good writing space. Okay, so after compression, if you uh, write or if you save your data inside a HDFS means space also it will save, right? Okay, because it is applying compression technique. Okay, for example, if you have 10 MB, if you apply compression technique, maybe it will come 6 MB or 7 MB. That means 3 MB or 4 MB space it will save. Okay, so these three advantages in file formats. Okay, so first one, text file format. Okay, so text file format behavior, basically end of each line, okay, it should terminated by a new line character. Okay, also uh, performance wise it will give a good write performance, okay, but data retrieval basically it will be bit slow, like whenever you are trying to read your data compared to write operation, reads will be slow in a text file format, okay. Also text file format generally it doesn't apply uh, any kind of a compression technique. If it is size, actual size is 1 TB, 1 TB space is required, so compression technique it will not apply, okay. And the second one, sequence file format, okay. So sequence file format basically it will store your data in binary format, okay. In that binary format also key value pair format it will save key value pair, okay. And also if you want to merge 2 3 files in a single file, okay, it will do, okay. So you can merge files into single file, okay. So that is about the behavior of sequence file format. Also read and write, okay. So write it will give good performance compared to your text files. Also read also it will give good performance here, okay. And compression technique, sequence file it is supporting, okay. So compression technique available. Okay, so basically these all backend it will take care. Okay, in create statement just we are adding a stored as ORC or stored as sequence, but backend these three automatically it will apply. Okay, your Hive framework will take care. Okay, and the next Yavro file. Okay, so Yavro file basically it is a file format and also serialization and a deserialization concept it will apply. Okay, so basically this serialization deserialization available in core Java, okay. And read and write operations of read average performance, okay. Also next RC file format. So RC file format behavior basically it is similar to your sequence file format, okay. RC file format is similar to sequence file format. Also if you want to perform multiple rows at a time, okay, so you can use RC file format, okay. And here reading is very fast, data retrieval or reading is very fast, but compromise with the writes, that means write it will be very slow, okay. And the ORC file, so ORC file compared to your RC file format, ORC file is better, okay, better. Also faster reads and writes it is very slow. And coming to Parquet file, so Parquet file it is just a columnar file format, okay, similar to RC and ORC only, okay. So here faster reads and slow writes, okay. So these all are the 6 file formats, okay. So query wise just end of the query we have to write only stored as then a file format name, okay. But the backend it will behave different, okay. So like compression technique it will apply, okay. And performance also reads and writes, okay, based on your file format it will behave, okay. So this is about file formats.
Thanks for watching this video. Also please subscribe our channel for more training related videos. Also share it with your friends. Bye friends.